welcome to my presentation. The title is MTMD, a multitask, multi-domain framework for unified ad lightweight ranking at Pinterest. Here is the delivery funnel. So at the very upper funnel, we have all the ads inventory. After that, by retrieval, budgeting, and pacing, followed by ads lightweight ranking, which is the main topic of today's presentation. After that, there would be heavyweight ranking and auction. So L1 has a high throughput. It's a latency critical task. That's why two-tower is still popular today for its fast inference purpose. So the main question for this work is how to handle all downstream tasks together for L1. Some background knowledge. Before this work, we have 9 production models for L1 ranking. It's categorized by the surface and the prediction task. We have 3 surface: home feed, related pin, and search. We have many prediction tasks like CTR, JCTR, conversion rate, relevance, etc. So there are many problems with this fragmented approach. The first problem is the data fragmentation. We could have more training data and more supervision signal. For example, if we predict video view using all the video format ads, instead of just the ads optimized for video view, then it can increase the number of training data by an order of magnitude. Then for a single training example, we have separate models for CTR and JCTR prediction. We could leverage more label supervision signal if we putting them together. Then for a single user and a single pin, we have separate models on different surface. We could have more training data to learning some embeddings. Second problem is naive handling of domain-specific features. There are domain-specific features, for example, shopping-only features like the item, the brand, the price. There are view type only features like the subject pin, related pin. There is search query in search. Right now, we treat them as missing and use the default value. The third problem is the calibration on specific domain and slice. Because we have different model for different slice, then naturally they can have different calibration. In ads, calibration is very important because they are directly used in auction. The last one is the maintenance cost and dev velocity, because there are so many models. Every time we push for a change, you need to touch a lot of models. That's hard for daily work. So in this paper, we propose MTMD, multitask multi-domain model. It's one model to serve all predictions for all view types, both standard and shopping ads. So this teaser figure shows the detailed model architecture. I would skip and introduce every detailed module. So overall, it's still a two-tower model. The top half is the item tower. The bottom half is a query tower. So after you derive the embedding, you still use dot product for inference. But within each tower, it can be very complex based on a concept we propose as a domain expert, which I will introduce here. So let's zoom into the content side, the pin model. Pin model has a domain adaptation module followed by 2 domain expert tower for 2 production types respectively. Then each task has an MLP for its own prediction. Let's discuss the domain adaptation module and the zoom in the domain expert here. So this is a domain adaptation module. For all the continuous feature, we go through batch norm, then we adopt the SC block together with the dense embedding vectors. Some of the categorical feature will feed into a specific expert depending on where those categorical features are from. Then this is the domain expert tower. So on the left is a domain-specific categorical feature. We would build a shallow expert on top of those per prediction task. On the right, after the domain adaptation module, we will have a deep expert for each task. Then we will create a task shared expert and a domain shared expert. Those two are aimed for capturing the global information. Then we will have expert routing to put the output together, followed by a DCN module for the better feature crossing purpose. After that, there would be linear projection per task. Then the projection result would be concatenated with the shallow tower on the left to construct the embedding for each task. That's how domain expert works. It's shared across all the towers. Then putting together, if you have the domain adaptation module and you have the domain expert, followed by the prediction task. That would be the pin-tower model architecture, like this. Similarly, you can do this for the query tower. I would omit. The only difference is we have 3 towers per surface. Here is the offline result. We can see we achieve 20 to 30% offline loss reduction improvement, which is huge. This happens across all the surface and all the prediction tasks and all the edit type, so it's quite encouraging. Then we bring this to online across different surface and different edge type and different prediction task. We see significant online metric improvement, like CTR by 2 to 3%, like CPC by 1 to 3% reduction. This model launch is one of the biggest launch ever in L1's history at Pinterest. Here is an ablation study which factor contributes to this model architecture. Apparently, the domain adaptation module, DCNV2 projection module, feature normalization, and the downsampling of training data, they all contributed to the performance. The other one impact is by domain adaptation, proper normalization, and the DCN feature crossing. A smaller embedding dimension and downsampling of the data can slightly hurt the performance, which is not a surprise. Thank you.